So difference quotient is something that you guys learned in pre-calculus, okay? And it sounds very confusing and it looks very confusing, but it's really not very confusing. So let's start off with a quick review. Okay, so if I have f of x is equal to x squared minus 2x, okay? And if I ask you what is f of 1, then you should be able to do that, right? And yes, if I do that, then f of 1 means wherever you see x, you replace all your x value, every single x with 1. So this becomes 1 squared, which is 1, and 2 times 1, which is 2. So you end up with a minus 2. So f of 1 is equal to negative 1. And keep in mind, right, that this is really a point. This was the x value. This is your y value. So this is really the point 1 comma minus 1. Okay. Now, likewise, I can ask you, what is f of minus 5? And f of minus 5 means wherever you see x, you replace all your x value, it's negative 5. 1 second. So we're going to replace all of the x values with negative 5. So negative 5 squared minus 2 times negative 5. Keep in mind, negative 5 squared means negative 5 times negative 5. So this is 25, and a negative 2 times a negative 5 becomes plus 10. So f of negative 5 becomes 35. Keep in mind, this is the x and that's the y. So it's very important that you guys understand what's happening. Now, the problem is that when we give letters, this becomes a problem. I don't know why, because I am 100% sure every single one of you can do what I just showed you here. Okay? The problem is that if we tell you that f of x is equal to x squared minus 2x, and then I ask you what is f of a, things starts to get a little bit fuzzy. It's the same process. Wherever you see x, replace your x with a. So now it becomes a squared minus 2a. Okay? Or if I tell you that f of x is equal to x squared minus 2x, and I ask you what is f of x plus h, then it means replace all your x value with x plus h. Okay? So this becomes x plus h quantity squared minus 2 times x plus h. And simplifying, you get x plus h times x plus h minus 2 times x plus h. And obviously, you guys could simplify this by falling this out. You will get x squared plus 2xh plus h squared minus 2x minus 2h. Oops. 2h. Okay. So why am I reviewing this? Because the difference quotient formula is f of x plus h minus f of x, everything divided by h. And I don't know who you guys had for pre-calculus, but this was supposed to be have drilled in you in pre-calculus. This is the difference quotient. And in calculus, you will see the importance of it when we start the next chapter. Okay. So if I give you f of x, can you find f of x plus h? F of x, the function is generally given, right? So example, if I tell you that g of x is equal to 2x plus 1, and I ask the question, what kind of a function is this? What do you tell me? This is like if we're in a classroom, right? So you guys will speak. So what kind of a function is g of x?
Linear.
Linear, very good, right? This is linear. And tell me some of the things you know about linear. What can you tell about a linear function?
It's a straight line.
It's a straight line. Very good. What else can you tell?
2, it doesn't have a, call it again, sorry. You know, the number above, the little number above, what we call it again?
Can you speak up for me? I can hardly hear you.
I'm saying it doesn't have a, what do we call it again?
The power.
Above, power. It doesn't have a power. The power is 1, sorry. The power is
The
1.
power is 1, yes, that is true. What else can you tell us?
It has constant rate of change and its slope is that constant.
Right, so the slope m is equal to 2. Do you agree with that? Right?
Yes,
And you
because
can
slope
also,
is usually the number that hugs the x. That's how I learned it.
right, when y is by itself, right?
Yeah.
Yeah, and you can also tell by looking at this that the y-intercept is 0, 1. Okay, now, suppose I ask you, what is g of 4? Can you find that for me? What is the value of g of 4?
9.
G of 4 is 9. That is 100% correct. So this was part 1. Part 2, suppose I ask you, what is g of x plus h? Can you find that for me?
2x plus h plus 1.
No, take your time. Get paper, guys. You can't do this in your head, right? You guys will need to have paper.
That's went fast.
2x plus 2h plus 1.
Yes. So it'll be 2x plus h in parentheses plus 1. Right? And when you distribute, you get 2x plus 2h, not 2x plus h plus 1. You agree with that?
Yes.
Now, suppose, so realistically, part 3 now, what is g of x plus h minus g of x, g of h, g of x, sorry. G of x, everything divided by h. Well, remember, g of x was given to you, right? You have this. This is a given. Okay? G of x was given to you. And you just found g of x plus h. This is your g of x plus h. So let's plug those things that we just found in. So instead of this, and it probably will be wise if you keep these in brackets. So this becomes
2x plus 2h.
2x plus 2h plus 1 minus, especially this here, keep this in brackets, g of x was given to you as 2x plus 1. Everything over h. Okay? Simplifying, you have 2x plus 2h plus 1. When you distribute the negative, you get minus 2x minus 1. Everything over h. And guys, when you use different quotient, things will always cancel, always. Notice that this is going to cancel with this, and this is going to cancel with that. You with me?
Yes.
What are you left with? You're left with
2h over h.
over h, which is equal to 2. Do you see any connection?
Slope.
Yes. Connection, slope. So the reason why you were supposed to be drilled about this in pre-calculus is because in our life right now, we can look at any linear equation and we can identify the slope. Okay? However, you will see in chapter 3 of calculus, because you're in the middle of chapter 2 and you haven't seen this yet, you will see in chapter 3 that slope tells the steepness of a line. And if the line is not linear, the slope is different at every single point on the line, right? So when a line is linear, okay, m here, if m is equal to 5, m here is equal to 5, m here is equal to 5, any point on the line, m will be 5 at any given point. Doesn't matter where it is. The slope is consistent at every single point for a linear line.
Guys, don't forget to turn off your microphones when you don't talk.
Okay? So that's it for linear. Now, when it's nonlinear, meaning some curve, I don't care what it is, right? Look at this. Remember, slope tells steepness, right? If you had to guess just by sign, what would you tell me the slope of that dark line there, positive or negative? Just the slope of this little line here. Is it
Negative.
positive? It's negative, it's going downward, right? But look at the slope here. What is the slope of that little piece of the line?
Positive.
Positive. So m here, all you can tell me, m is negative. Here you can tell me m is positive. So the slope of non-linear lines changes at every single value. In calculus, we call, or in limits, we refer to those values as some c, right? X equals c. So you will see that the difference quotient will really find the slope of the general function, okay? And if you want the slope at any given c value, you plug c into the function. Now, half of you are probably lost with what I just said there. Am I correct?
Yes, you are.
Okay, good. So here is visually what I'm saying. So let's look at this example. And everyone should be able to tell me the equation of this function that I just drew here.
X squared.
You're very close, but not correct.
Plus 1.
1, 2. Shoot.
Somebody said it.
Plus 1.
Plus 1.
X
Yeah.
squared plus 1.
Yep. X squared plus 1. Okay. Now, if I ask you the question, let's say here is, this is drawn really sloppy. Let's say here is -1 and here is +1. Okay. If I ask you what is the slope here, what is m at that point? What can you tell me? Right now, just by looking at the picture, what can you tell me?
2.
The coordinate is 1, 2.
Yeah.
The coordinate is 1,
No,
2. You don't know that.
It's 2.
Okay.
Positive. Positive.
Guys, wait, stop. Can you guys see my picture?
Mm-hmm.
Everyone can see me?
Yes.
No, your picture? No, your personal picture.
Oh, no, I can't. Yeah.
No, we're not seeing your picture.
You don't see me on the computer screen?
No.
No.
we're
I
just
see
seeing
you.
your-
see you.
I don't see
Near
you.
the top of my screen with your drawing below.
Well, listen, you guys should be able to see me. If you don't see me, run. So I must be ghost to some of you. Alberto, can you see me?
Yeah, you're at the top of my screen. Drawing is below you.
Okay, Molly, are you here, Molly?
Yes, I am, Professor.
Can you see me?
I can, sir.
Okay, Molly, am I male or female?
You're a male.
I look male.
Yes.
Okay. Be careful how you speak, Molly. Right?
Right.
Now, there's some things you can tell just by looks. You may not be 100%, but you can probably get a general idea. Just like when you pick up a book. Remember when you guys used to read books, you used to turn to the back of the book and just read the cover and say, oh, I know what this book is generally about, right? When you look at this graph, you can tell where that red dot is. M is positive. You don't know it is 2,
Oh.
right? How do you know that this point on the y-axis wasn't 5? You assumed it's 2.
Oh, yeah, you don't
Make
know.
assumptions, right? I'm waiting for someone to say something, but nobody's saying anything.
I was gonna say positive, but I was just waiting.
Well, that point is 2. And how do you know that?
Because the graph, oops, am I talking? Because if below it's 1,
Right,
and
exactly.
the curves are
That's
equal,
1.
the next one would be 2.
And you know this is 1 because I said plus 1,
Plus 1, right?
right?
Yeah.
So telling me that point, I think someone said that point is 1, 2. You were correct. But so here, what all you can tell me right now is M is positive. If I ask you what is M here, what will you tell me? M is positive.
Positive.
If I ask you what is M over here, what do you tell me?
M is
It's negative.
negative.
Now, so that's from a picture perspective. Now, suppose I tell you, so here's my question, example. What do we call this function? G of x. G of x is equal to x squared plus 1, okay? Can you find the difference quotient? Use difference quotient. Okay? Which is g of x plus h minus g of x over h. And simplify. So can you do that for me, please? Do you think you can do this?
First,
G of x equal.
You
x
can't do this in your head. You need a pen and paper. Please, guys, get pen. Anytime we have lecture, get pen and paper, okay? So give me the value of the difference quotient when g of x is x squared plus 1. What is the difference quotient equivalent to? Work it out. Take a minute.
Yes.
So let's see what the answer is. So we know g of x, right? So you were given g of x is equal to x plus 1. But at some point, we need to figure out what is g of x plus h. So let's do that right now. What is g of x plus h? Well, it means that wherever we see x, we're going to replace it with x plus h. So x plus h squared plus 1. Simplifying this, okay, this becomes x squared plus 2xh plus 8 squared, and then we bring down the plus 1. Okay. Now we're going to apply the difference quotient formula. The difference quotient formula is g of x plus h minus g of x, everything over h. Plugging in the numbers, so this is this here. So we have x squared plus 2xh plus 8 squared plus 1 minus, keep that g of x in parentheses, which was x squared plus 1. Everything over h. Okay? So we have x squared plus 2xh plus 8 squared plus 1 minus x squared minus 1. Everything over h. And like I said, things gonna always cancel. This will cancel with this. Okay? This here is gonna cancel with that there. So what are we left with? We're left with 2xh plus 8 squared over h, which is equal to 2xh over h plus 8 squared over h, which can be simplified to 2x plus h. Do you agree with that?
Yes.
Yes.
Good. Now, here is where the so this is what you learned in pre-calculus, right? This is what you learned in pre-calculus.
Yes.
Now, let me ask you a question, okay? Suppose I ask you now, what is the limit, okay, as x approaches 1 of 2x plus h, assume h is approaching 0. this means h is 0. What will be the limit?
Point.
What?
I wanted to say point something.
Guys, is this a continuous function?
Is the limit 1?
Yeah, no, not 1, 2. You can do direct substitution. This means 2 times 1. This one
plus h.
is 1 here. Plus 0. I said h is approaching 0. So this is equal to 2. So what does this mean? This means the slope is 2 when x is equal to 1. If you go back and you look in the graph, when x is 1, guys, was the slope at least a positive number or was it a negative number?
Positive.
Positive.
Positive. Did we get a positive result?
Yes.
Yes. So this is more of a chapter 3. We're going to talk more about this in chapter 3, but you guys asked me to review difference quotient. This is the review of the difference quotient. Okay?
Mhm.
Questions?
Yeah, Professor. Sorry, I missed it, or I just didn't get it. Why do we assume that h is 0?
You will learn that in the next chapter in calculus.
Cool. All right.
Right? I gave you that. I'm telling you, assume h goes to 0. Now in pre-calculus, we call it h. In calculus, that h is being chosen as delta x. You guys know what delta x is?
Change over. Right.
So yeah, you know delta mean the change in x, right?
Mhm.
When we speak of a delta x is a very, 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 very small x value. It is so small, it's less than the measurement of the thickness of your hair in your head, if you have hair, by the way. Okay?
Mhm.
It's a very, very small, it's like 0.00000000001. It's a very, very small value. It is so small that we think it's 0. And that's what you will see in chapter 3. Okay. Okay. In my class notes, it says that limit is really the height of the function at a given value. So for example, if I have the XY axis, okay, and I don't care what the graph is. Let's say this is the graph, call it h of x. And I tell you that this is 1, this is 1, 2, 3. Okay. Here is -1, here is -2. And I ask you, what is the height? What is the height of h of x when x is equal to -2? What would you tell me? Here's the picture.
Approximately 0.9.
It got to be Alberto just spoke there, right?
Yeah.
Yeah, I know. You always got to make my life difficult. Here, how about that now?
1.
All right, now he tells me 1. Yeah, it was close to 1. You were right, but right. At -2, you go up. The height of the function is 1, isn't it?
Yes.
That's it. So this is the same as if I asked you the limit as x approaches -2 of h of x. And that is equal to 1. Now, keep in mind, this means x approaches. Okay? And that's why in your class notes, and guys, if you're not reading the class notes and you're not watching the videos them on WebAssign, you are making calculus 60% of it, it will be difficult for you, extremely difficult. You guys all know where to find the class notes, right?
Yeah.
Okay. Good. And you know where the videos are, correct?
No, I'm not seeing the videos. I know the class notes, but I'm not seeing the video.
Okay, did you look at my Zoom video for the very first class meeting?
Yes.
Okay, I explained there where it was. So when you look at your class, hold on, don't look at my screen right now because it's going to be different from your screen. So let me go on what your screen looked like. When you log into WebAssign, your screen looks like this.
Yes.
Most times, yeah.
Okay, and somewhere on this screen is going to say resources. I don't remember where I pointed out the last time, but it says resources somewhere here.
At the bottom.
Down to the bottom here, resources. This is your textbook, you click on it. You're in chapter 2, that's it. We're doing limits graphically, 2.2, that's it. You want a video? There is a video. Click on it. Click on it.
Take a look at this function. It's a
And there, the
fraction,
guy is talking,
and
right? If I
notice what
turn
would
up my
happen if we
volume,
replaced x with 2. In the denominator, we would have
I
2
don't know if
minus
you
2,
guys can
0.
hear.
2 times the 0 would be
My
0.
volume's not
The
turning.
function is not defined at x equals 2, and yet we want to find the limit of the
Right?
function
So
as x
you need to watch
approaches
these
2.
videos. They're very
Now,
short.
x
This one is
approaching
only
2, that's an
4
interesting
minutes.
idea. As x gets really
This
close
one
to
here will be
the function is sine 1 over x.
3 minutes.
And we're thinking about the limit as
There
x
are
approaches
tons of
0.
video here to help you.
Now, this is an
Okay.
oscillating function.
So please make
Yeah.
sure you look at them.
It's very helpful.
Yeah. Now, the reason why we say approaches is because in your class notes, okay, if I give you, for example, let's see if I use the one that was in the book that I gave you. A similar example that I tell you that f of x, this was from the class notes. I think I used x cubed minus, actually I didn't use this one, but let's use this one, x minus 1. Okay. Now, this, or if you want, you can write x minus 1 times x squared plus x plus 1 over x minus 1. Okay? This will cancel with this, leaving you with x squared plus x plus 1. But when you draw the graph of this, you will see that your graph is a parabola, okay? But, oops. Is a parabola, but there is a hole there. And the reason why there is a hole, because at x equal 1, there is a problem. Why is this a problem? Or why do I say it's a problem? Why is this a problem? Anyone?
Denominator becomes 0 and we cannot divide by 0, so function is undefined.
Right, the denominator becomes 0, and that's why it's a problem. Okay? So there's a hole in the graph. Now, if I ask you, what is f of 1? F of 1 is not defined, right? Because f of x is equal to x cubed minus 1 over x minus 1. F of 1 is 1 cubed minus 1 over 1 minus 1, which is I don't care over 0, problem. Can't happen. No, no, no. One more time. Can never have 0 in the denominator. So f of 1 is not defined. Okay? It's not defined at all. Can't happen. And that's why we get a hole. Now, the next section that you will do, which is, I believe, 2.4, you're going to see something happens here right? Where I scratched off these things. Okay? So you'll see that happening today, or at least the next time I post notes. Okay? So that's the problem. Now, and that's why we say approach, because we're saying now, as you travel, pay attention now, pay attention. This is where x is equal to 1. Actually, I should do that in pencil. This is the point where x is 1, right? Now, keep in mind the graph here, x is 1. Now, as you travel on the graph, going towards 1. And the way we write that, limit-wise, we say the limit as x approaches 1 from the right. You see that little plus sign that I put there?
Mhm.
This means the limit as x approaches 1 from the right.
Because that's the positive side.
That's a positive sign, yes. On this side here, okay, on this side here, when you travel this way, okay, the way we would write that is the limit
Approaches.
as x approaches 1 from the
Negative.
left.
Right.
Keep in mind, it's not -1, right?
Oh, it's left.
It's 1 with a minus on that top there,
Oh, okay.
okay? And on this side, it's 1 with a plus on the top.
Mm.
So you're approaching the number 1, but from the right side. Here you're approaching the number 1, but from the left side. So remember, f of 1 is not defined. But if I ask you what is the limit as x approaches 1 of f of x, when you do that table of values, guys, okay? When you do your table of values, all right, x and f of x, and you're looking at 1, put 1 in the middle and put some values here, which will be 1.001, 1.01, 1.1. Some value from the left will be 0.999, 0.99, and let's say 0.9. Does everyone understand how I'm getting these values?
No.
No. Okay. This is simple, basic algebra, okay? But because you're doing it for the first time, it may look, here is 1, all right? You want some values very, very close, so close that they're like touching. What number is just past 1? 1.1 is too far. 1.1 is all the way over here. So 1.1 is too far. I want values very, 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 very close to 1. So close you can feel it breathing on you.
0.999.
No, 1.0.
No,
You're on the right.
0.00.
It has to be past 1, right?
1.0001.
That's where I'm getting that value from.
Oh, okay.
All right?
Yeah.
So,
And what's
you
some-
basically add
what-
plus 0.00.
What is it?
I mean, you add 0.001 to 1, like,
Yeah. You take 1 and you add 0.0001 if you want 3 decimal, or if you want 0.001 or 0.01. These are the 3 numbers I always add. And then what do you do on the other side? You take 1 and you minus 0.0001. And then you minus 0.001. And then you minus 0.01. Those are how I'm getting these values here. Right? So what's a number very, very close to 1 now from the left side? 0.99999. So if you want to use 4 digits, you could use 4. It doesn't matter. Okay? I'm going to use 3 for practice purposes. Okay? So what is f? If you figure what is f of 0.9, the answer would be 2.71. 2.710. What is f of 0.99? The answer is 2.970. What is f of 0.999? The answer is 2.997. F of 0 is F of 1 is undefined. We knew that. Okay, let me write properly. Undefined. Oops, come on. Undefined, right? How do we know that? Because we got that from here. It is undefined. Okay. What is f of 1.001? Well, f of 1.001, we found out that value. That value is 3.003. What is f of 1.01? If you do it, you'll get 3.030. And f of 1.1 is 3.310. Now, what we want to do, guys, is compare this value and this value here. What number do you think they're meeting up at?
1.
Maybe 3.
3.
3.
Yeah.
If this is a 3.003, which is almost 3, and this is 2.999, that's almost 3.
Right.
They're meeting up at 3,
Yes.
right?
Right.
So the limit as x approaches 1 of f x cubed minus 1 over x minus 1 is equal to 3. Why? Because this value is very, very close to that value. If this was -3 and this was positive, then they don't meet. They have to be very, very close for it to say they meet. Okay?
Mm-hmm.
Any questions on this? Questions?
That 2.7, I know x is the number for x. How do you get the value for f of x at 2.71?
If I give you f of x and I ask you to find f of 1, what do you do?
I substitute.
Okay, you just answered your own question, right? When I give you f of x, okay, when I give you x here is 0.9, and you know f of x, all you're doing is taking in this and plug it into here and simplify it.
Because it's cubed, yes, get it.
Okay.
Okay, I get it. No, I get it. I didn't know we're doing it from all the way up there.
Okay, so after my class today, I'm going for breakfast at the diner. Okay.
I know.
And
Oh, go ahead.
I'm gonna ask Jaden to meet me there. I'm gonna ask Christopher. Is that how you pronounce your name? Christopher? No?
That's right.
Molly, you're there? Oh, Christopher, okay. Christopher and Molly. Molly, you were there earlier, right? No? Molly left, okay. Tatiana, here? Is anybody here?
I'm here.
Okay,
I'm here. I was just in my kitchen.
yes. So we're all home, right? Let's look at this scenario. We're all home. So I live at H1. I know Jaden live at, so let's call this M. Jaden live at 2. I don't know where he lives, but he lives somewhere. Who else answered? Who else did we pick?
Molly.
Molly and who else? Molly. Let's call this 3. And somebody else answered. Whoever. I don't care. I think was A. Okay. Let's call this 4. So we're gonna all meet up at the diner. You guys meeting me, right? If you meet me, you get an A. Are we going?
Yeah.
Yes.
Or of course. Everybody's gonna want to go now. All right.
No, I'm not going.
At 12 o'clock, meet me at the diner. If I don't see you, get an F. We all good?
Yes, we are.
Okay, I'll see you guys there at 12 o'clock. Good, let's move on. You guys are a bunch of liars, you know. How the hell are you gonna meet me at the diner? Nobody's asking me where is this diner.
We're waiting for you to tell us.
No, you don't wait for me to tell you, ask questions. This is the problem now, is that everybody waits for ask for. Yeah. None of you would be able to meet me, so that means the limit wouldn't have existed because we never met. Please put your phones on mute if you're not talking, guys. Okay. Now, if the diner is somewhere over here, okay, and I went to the diner, and Jaden went to the diner, but Molly and the other person decide to go to this diner here. Did we all meet up?
No.
No. Therefore, the limit doesn't exist. For you to say the limit exists, the limit would exist only for these two individual or these two individual. Okay? So for limit, we generally look at two. We look from the left and the right. So if you have some road to take to get to the diner, and another road to take to get to the diner, and let's say I'm here and Alberto is here, we both meet up at the diner, then that's what limit is. If you don't meet, the limit doesn't exist. Okay?
Ah,
So look at this graph. Look at this graph. Let's call this function g of x. Okay? Let's put some value, 1, -1, 1. Let's put it over there. Yeah. Let's say this is 1. Oops. Let's say this is 1 also. Here is -1. What is the limit as x approaches -1 for g of x?
1. No. Doesn't exist.
No, it doesn't doesn't exist.
Limit doesn't exist. That is right. Because here, this
Neither.
is Mark,
Yeah.
this is Mark, this is Jaden. Do we meet up?
No.
No.
At -1, which is here, do we both meet up?
No.
No.
No, we don't. So, does not exist.
Exist.
Okay?
Mm-hmm. Yeah.
Look at this picture now. Call this h of x. Call this here 1. What is the limit as x approaches 1 of h of x?
1
Let's
plus
call this point here 2. I don't know.
2 plus.
Well, assuming it's right there. So what's the limit here now?
2 plus.
2, not 2 plus, 2,
2.
Okay.
Mhm.
right? Why? Because if you travel from this side here, what's the height there?
2.
2, right? If you travel on the graph, you're going to stop at a height of 2. If I travel on this side, you're going to stop at a height of 2.
2.
So the limit from the left is 2. The limit from the right is 2. Therefore, the answer is 2.
Mm-hmm. The meeting.
Okay? If you look at this picture here, Let's call this P of X. What is the limit as
Undefined.
X approaches 1 of P of X?
Undefined.
Please use your word wisely.
Sorry,
not
doesn't
exist.
exist. Doesn't exist. Sorry,
Does not
exist.
exist. Okay? Why? Because when I travel on this side, I'm at a height here. I don't care what that value is. Let's say 2. When you travel on this side, you're at some negative value. We're not at the same value, is it?
No.
But keep in mind, right? So the limit doesn't exist, but is P of 1 defined? Is P of 1 defined?
Yes.
Yes.
Yes, P of 1 is defined. It will be this height here if that's 2.
Mm-hmm.
So P of 1 is equal to 2. But the limit doesn't exist at X equals 1.
Mm-hmm.
Do you see the difference?
Yes.
Okay. So generally, we can say that we can use a direct plug-in or a direct substitution when the function is continuous. Okay. Questions? Anyone have any questions before we move on?
I just saw in chat that we're supposed to download the Maple graph before we go into that lab today.
Yes, that was sent out via email. Professor Ali said that in his email, and he showed you the steps how to get it too.
Let me look back.
So remember, you guys are an online class, right? Reading is very important, what you guys do now.
His email, but what I downloaded was the calendar that he said I was to download for his class every week.
I wouldn't download the calendar yet until Professor Ali is going to join us at 10:30 if he's not here as yet.
Oh, so it's the same thing we're going to be on. Okay.
Actually, I don't know. That's a good question. Because I saw he did send out a calendar. You're right. Was there a date, today's date on that calendar?
Yes, it was.
So then you'll have to log out from me and log into his May 29th. Yes, you guys will have to leave me. I'm going to join his session then at 10:30. So you know what? I'm not going to even get into the next, or briefly, let's just quickly talk about it, right? Because I want to be there with you guys for the first few minutes. Because for some reason, if I'm there, we'll probably get accomplished more in the first 5 minutes than that. The first 5 minutes, we'll just decide when labs will be. Yeah. Now, since how many people are on? 18, but a lot of people just log on and they're not even here. Because if I take attendance, I'm sure only about 8 or 9 of you are active.
Okay.
You don't attend these sessions that I'm doing. It is mandatory that you attend labs, but I talked to Professor Ali about that. He is your lab professor, okay? So I don't want to make decisions based on you guys and him. I prefer you guys to work it out with him. So I am going to be there just to hear what's going on and voice my opinions periodically. Okay. Now, moving ahead to next week. Okay. Next week, which is Monday. It sounds like 4 now. You guys will start section 2.4, right? How many engineers are in this class? Engineers? Speak if you're an engineer. No one is an electrical engineer or any type of engineer for this class?
I'm going for mechanical, Professor.
Okay, so for any engineers in this class, computer engineer, mechanical engineer, electrical engineer, there is something called the squeeze theorem, which I hardly elaborated on my notes, okay? It's in the textbook. You guys have the ebook. It's on page 89. Please understand what the squeeze theorem is, okay? The engineer used that more than anyone else. It's called the squeeze theorem. It's basically when you have, you want to find a limit or 2 or more graph, and one of the graph is sandwiched. Another name for the squeeze theorem is the sandwich also. It's sandwiched between, one graph is sandwiched between 2 graphs. That's very, in actuality, funny enough, guys. Remember just now I was talking, you were talking, and someone was talking in the background and the video playing?
Yes.
That would have been the squeeze theorem right there. Because I'm talking, you're talking, and the video is somewhere in between, right? You guys were hearing that video, right?
Mhm.
And that's the squeeze theorem. It's sort of like between two graphs. Let's read it up a little. You can look at videos online for squeeze theorem. You will see squeeze theorem in your life again for you engineers. Okay. Okay, so the next section we want to talk about is what is called continuity and one-sided limit. So when we were looking at limits before, we said we were traveling with limits from the left side and from the right side, right? Well, sometimes we can only look at limit from one side, and that's called one-sided limit. And that's where you're going to see these two notations that I showed you earlier, the plus and the minus. These two notations, they're used a lot in one-sided limit, okay? So you will see more of that later on. All right. Also in this section, we talk about continuity. Continuity is the big thing in the next section, 2.4. What do we mean by something is continuous? Yeah. What do you understand if I say, I'm going to be teaching you guys continuously for the next 5 hours? What does that mean in English?
Non-stop.
Non-stop, no break, right? That's exactly what it means in math too. When we say a graph is continuous, okay, we're talking about a graph that has no breaks in it. The graph is continuous. There is no gap. So for example, if I draw this function here, this function is continuous because if I take my pen, pay attention, because I mentioned this in my notes. You don't have access to that notes yet, but I did. If I take my pen and I start out from the left side and I travel along that graph, did I reach the end of the graph without raising up my pen? Yes or no?
Yes.
Yes.
So this graph is continuous, okay? This graph is continuous, okay? On the other hand, if I have this graph here, okay, and I try to do this, there's a problem. Look, if I start here and I go, I didn't reach the end of the graph, right? I didn't reach the end of the graph. I have to raise my pen up, put it back down here, and then start a grade and continue again. So this is not continuous, okay? Not continuous, meaning the graph is discontinuous, right? The word for not continuous is discontinuous.
Right.
Make sense? If something is not continuous, it is discontinuous. And I know a lot of you in my class doesn't speak, English is not your first language, so please make sure, I mean, I give you guys credit, right? You have to understand this, okay? And there's two types of discontinuity. When something is discontinuous, there's two types of discontinuous, but we don't say that in English. We say there are two types of discontinuity. Discontinuity, okay? And you will see in the notes and in the videos that there are what they are and so forth. Because I'm going to stop there. You guys will get like a 5 or a 10-minute break before you log into Professor Ali's session. Any questions?
That email that he sent doesn't show me how to do the maple thing.
Yes, it does.
I'm looking.
I read that email.
It says here, hold on. The class will start at 9, but I will be, no, this is from you. Oh, sorry.
Yes.
Sorry.
Yeah, I don't have my email open on my iPad, so, but he did. He said you had to go on CUNY first and download it.
All right, I'm gonna look.
Professor, if I may,
When I use the time to go, can I leave the meeting and use the time to go now? Or
yeah, my meeting is ended, yes. I'm gonna stop the recording right now.